Welcome to this section where we will continue to work with the Riverpod package by implementing the authentication flows so that we can use our app to sign in and sign out and keep track of the user authentication state. And we'll do this by starting from the current project, which already includes the UI that is needed for the authentication flows. So by the end of this section, we'll be able to sign in with email and password using this form. And this in turn will update the authentication state so that we are allowed to open the orders and account pages when we are signed in. And from here, we'll be able to log out and get back to the initial state. And to enable this, we will add all the logic that is needed inside the data and presentation layers inside the authentication feature. So this will be a great opportunity to learn more about Riverpod, and it will also teach us how to implement a feature that spans across different layers in our architecture, focusing on one layer at a time. In fact, as part of this, we will implement an authentication repository, which will use a reactive in-memory database to store information about the authenticated user. And for our purposes, this will be good enough for now, and we will implement a proper authentication system using Firebase in the next course. Then we'll implement the logic for signing in and signing out. And as we will see, the best place to do this will be inside some controller classes that are based on state notifier and live inside the presentation layer. And we'll see how these controllers allow us to manage the widget state and talk to the repositories in the data layer. Along the way, we'll learn about the difference between ref.watch, ref.read, and ref.listen using Riverpod. And we'll also learn a few more tricks about async value, including how to use guards as a better alternative to try and catch blocks. And we'll wrap things up by implementing some redirection logic using GoRouter and prevent users from opening certain pages if they are not signed in. And as part of this, we will also implement a redirect listener, since this will allow us to automatically dismiss certain pages when the authentication state changes. And as we will see, we will need to combine GoRouter with Riverpod to accomplish this. In summary, this will be the first section where we will implement a real feature in our app, and we'll use this to learn about many essential concepts about Riverpod and GoRouter. And as a heads up, in the next section, we will write automated tests that will allow us to verify that the authentication flows work correctly. Okay, so let's continue in the next lesson. In this lesson, we'll start implementing a fake auth repository class, as this will define a clear interface that the rest of the app can use when it comes to authentication. So just like we have done when we have defined the fake products repository, we are going to define some methods that the rest of the app can use. But in contrast to the fake products repository that we can only use to read data, our fake auth repository will also hold some application state that we can change when we sign in or sign out. And as far as our project goes, we'll continue from where we left off in the previous section, and I already had the app running over here on the macOS simulator. So feel free to grab the starter project from the resources below if you need it. So without further ado, let's start implementing this by selecting the authentication folder, and then inside here we can add a new folder called data. And inside it we can create a new file called fakeauthrepository.dart. And inside here, we can create a class fake auth repository. And then let's add some methods for signing in and signing out. So the first one will return a future of type void, and we can call this signing with email and password. And this will take a string email and a string password as arguments. And we can mark this method as async, as we will need this later. And for now, we are going to leave the empty body with just a to-do inside it. Then we can add another method which also returns a future of type void, and we are going to call this createUser with email and password, which also takes the email and password as arguments. And we are also going to add a to-do inside the body. And just to be clear, we need both of these methods since we can both sign in or create an account when we use the sign in page. And finally, we also want to add a method that we can use to sign out, like this. Next up, we need to add a stream that we'll use to check the authentication state of the user. So over here, we can add a stream, and the type of this stream will be a nullable app user, like this. And this is a model class that we can import from this file. And this will be the return type of a method called authStateChanges. And for now, we are going to implement this as stream.value of null. And we can add a to-do so that we can remember to update this later. And just to be clear, this string will just return a single value of null, meaning that the user is not authenticated. And just for reference, we can open the definition of the app user class. And as you can see, this is just a class with two properties called UID and email. Okay, so let's get back to our repository. And over here, we can also add a getter variable that we will use to get the current user. So this will also be a nullable app user, and we can call it current user, and it will also return null by default. And as you can see, this does not use a future or a stream, because the idea here is to obtain the current user synchronously, and this is something that we will need later on. So all we have done until now is to define a repository with some methods that are needed for authentication purposes. And while these methods are not implemented, they already define a contract for how the rest of the app can talk to this repository. And as you build your own apps and create classes in the data layer, I also recommend that you do things in this order. That is, first decide what your API should look like, and then implement your methods. And now that we have this class, we need to implement a provider so that we can access this repository. So over here, we can type provider, and then we can call this auth repository provider, which should be a provider of type fake auth repository. And inside it, we should return an instance of fake auth repository. And of course, we need to import Flutter Riverpod in order to use this. And in addition to this, we will also need a stream provider that gives us access to this auth state changes method. So let's scroll down a bit, and here we can add a stream provider, and we can call this auth state changes provider. And the type of this stream provider will be a nullable app user. And then we can remove this async star annotation, and inside it, we can type final auth repository equals to ref.watch auth repository provider, and then we can return auth repository.auth state changes. And we also want to make sure to use auto dispose so that the connection to this stream is closed when we no longer need it. So this completes the public interface for our fake auth repository, but of course we still have to implement all these methods. So let's continue on the next lesson. In this lesson, I want to talk about creating repositories using abstract classes, which is something that is entirely optional. However, I want to cover it as it will help us see the bigger picture when working with repositories. And just to give you more context around this, we should keep in mind that here we are creating a fake auth repository, because we don't have a backend just yet. But at some point in the future, we will replace this with a real auth repository that uses Firebase under the hood. And as we will see, it would be convenient if there was a simple way to choose which repository to use based on some configuration or environment variable. So for the moment, I just want to give you a little preview of how we can do this. And the main idea here is to implement an abstract class called auth repository, which declares all the same methods that we have in the fake auth repository, including auth state changes, current user, sign in with email and password, create user with email and password, and sign out. And then we could make sure that this fake auth repository implements the auth repository. And as a result, we should also add the override annotation to all these methods, like this. And since we now have this base abstract class, we can also create a new class called Firebase auth repository, which also implements auth repository. And this class would have to implement all the methods of the base class. And then we could implement all these methods by using the Firebase auth package under the hood. And this is something that we will cover in detail in the next course about Flutter and Firebase. But the point that I'm trying to make here is that by introducing a base abstract class, then we can have multiple implementation of it, such as the Firebase auth repository and the fake auth repository. However, if we scroll down to the declaration of our provider, then here we can change the type of this provider to auth repository. And then inside the body of the provider, we can choose whether to return a concrete instance of fake auth repository or Firebase auth repository. And this can be done in many ways. For example, we could read an environment variable using this syntax and check if its value is true or false. And this is something that we can set when we compile our app using Dart define as a command line argument. And once we have this, we could use the ternary operator to choose between the fake auth repository and the Firebase auth repository. And the benefit of this is that we now have an easy way to switch between the fake auth repository and the real one, without having to make any changes to the rest of the codebase. In fact, we can already see that all this auth state changes provider does is to watch the auth repository provider. And then it can call the same auth state changes method, because this is now defined inside the base abstract class. And at runtime, the correct repository will be chosen based on this environment variable. And this same concept applies not only to this auth repository, but also to all the other repositories in our app. However, it does mean that for every new repository that we create, we also had to create a corresponding abstract class and implement all the method overrides. And we won't really get any benefit from doing this until we implement the new repositories using Firebase. And this is something that we will only do in the next course. So for now, we're going to make our life easier and not use any abstract classes at this stage. So what I'm going to do is to undo all the changes that I've made in this lesson and get back to just having a single fake auto repository without any abstract classes. And the main takeaway of this lesson is that as long as we define clear interfaces for how different components of the app can communicate with each other, then it becomes easy to change the implementation later on without affecting the rest of the codebase. In any case, if you head over to my website, you can find this article about the repository pattern. And this explains the technique that I've just covered in more detail. And this article also explains how to write automated tests for our repositories, which is something that we will cover in more detail in the next section. Okay, so let's continue on the next lesson. Before we can implement all the methods in this repository, we need to focus on one important requirement. And that is that we need to create a reactive in-memory store that we can use to track the authentication state changes, as this will serve as a substitute for Firebase authentication or any other authentication service that you may wish to use in your app. And the main focus here is on these two words, reactive and in-memory. So what does reactive mean and why do we need it? Well, the idea here is that the authentication state of the user is something that can change over time. For example, when we first start the app, we may be signed out. And once we sign in and create an account, then we'll have a logged in user, which is identified by the UID and email. And as we know, we already have an app user class that was created for this purpose. Of course, once we are signed in, we can sign out again. And as a result, the authentication state changes again. And of course, this authentication state determines the actions that we see on the home app bar, as well as other pages in the UI. And because this state can change over time, it is best represented as a stream that we can listen to by watching a stream provider. And this is what makes our store reactive, because we need to be able to rebuild certain widgets when the authentication state changes. Next up, let's focus on the in-memory part. And like I said, we don't have a real authentication system just yet. In fact, we are currently in the process of creating a fake auth repository, and we'll only create a real one in the second course, where we'll integrate the client app with Firebase. So just like we have built a fake products repository in the previous sections, creating a fake auth repository will be good enough for our purposes. But as we said, we need to be able to modify the authentication state, and this needs to be held either in memory or saved locally using some local storage system. And as far as we are concerned, saving this in memory will be fine for our purposes, as long as we remember that when we rebuild or hot restart our app, then the state will be reset to the initial value. And this bears one question, and that is, how can we build a reactive in-memory store that is based on streams? And one option would be to use a stream controller, which is a class that is part of the Dart async package and lets us add values to a stream that can be listened to in our widgets. However, we have two special requirements that we need to keep in mind. The first is that our output stream should support multiple listeners, and this is something that can be implemented by using the streamcontroller.broadcast API. But also, our stream should remember its last value, so that it can be returned immediately if a new widget is added as a listener. And while we could support multiple listeners by using streamcontroller.broadcast, this does not give us the ability to remember the last stream value, and it turns out that writing a custom implementation that does this is not easy. Instead, we can get everything we need out of the box by using behavior subject, which is a class that is available as part of the RxDart package. And while you could argue that it's not ideal to import an entire package just to use one class, in this case we'll make an exception and make our life easier. And now that I've given you an idea about what we are trying to do, we can continue on the next lesson where we'll implement our in-memory store. We are now ready to implement our in-memory store. And as we said, this will be based on RxDart. So the first thing that we need to do is to add a new dependency called RxDart. And once we do this, we should be able to open the pubspec.yaml file, and we can find it over here. And as usual, we can remove this caret to make sure that you use exactly the same version as mine as you make progress in the course. And then we can save to get the latest packages. And then we can get back to our fake auth repository. And if we wanted to get things up and running quickly, we could add a behavior subject directly over here. And this is something that will only compile if we import the RxDart package. However, let me point out that we will reuse our in-memory store for many other repositories in our app. And ideally, we don't want all repositories to depend directly on the rxdart package. For this reason, let me delete this code. And instead, what we want to do is to create a separate class that will live inside the utils folder in our project. So over here, we can create a new file and call it in-memory-store.dart. And inside, we can add a class in-memory-store, and this class will be generic on type T, so that we can reuse it in multiple places with different types. And inside it, we can add a property, which will be a final behavior subject of type T, and we can call it subject, like this. And in order to use it, we need to import rxdart. And we also want to add a constructor so that we can initialize this property. So let me take this constructor and move it over here. And as we can see, this subject is now added as an argument directly to the constructor. However, we don't really want to pass a behavior subject as an argument every time we create an in-memory store, because we want behavior subject to be an implementation detail of this class and not something that needs to be passed in from the outside. Instead, I propose that we remove this argument and pass an initial value of type T to this constructor. And then we can add a column to define an initializer list. And here we can type subject equal to a behavior subject of type T. And here we can use the .seeded method to pass the initial value that comes from the constructor. So once again, what this will do is to create our behavior subject and give it the initial value that we have passed in. And if this is not 100% clear at this stage, don't worry, because it will make a lot more sense once we start using this class. And now that we have added our constructor, we need to take care of the public interface of this class, which is what we will use from the outside. And if we recall, what we said about our in-memory store is that it should be reactive and give us a stream that we can listen to. So our next step is to define a stream of type T, and this will be a getter called stream, and this should return subject.stream, which is a property of our behavior subject. And in addition to this, we also want to be able to read the latest value inside the stream, and we want to be able to do that synchronously. And this is where behavior subject comes really handy, because we can add a getter variable called value with type T, and this can just return subject.value, like this. But getting this value is not enough, because we also want to be able to set it. And for that, we can define a custom setter, which takes a value argument of type T, and we can use this to add this value to the behavior subject. So what this will do is to take the value that is given to the setter and add it to our subject. And this will cause our stream to emit a new value if it's listened to. And we can also use this getter to access the new value synchronously. And since we are working with streams, we also need to add a method to close our behavior subject when we no longer need it. And this completes the implementation of our in-memory store. And I think it would be useful if we could add some documentation so that we know exactly what is the purpose of this class. So here it goes. This class is an in-memory store backed by behavior subject that can be used to store the data for all the fake repositories in the app. And this is the behavior subject that holds the data. This is the output stream that can be used to listen to the data. And we also need a synchronous getter for the current value, as well as a setter for updating the value. And we must not forget to call this method when we are done. And as you can see, these getters and setters are very simple, because all they do is to get and set the data by using the underlying behavior subject. But the advantage is that we can now use this in-memory store class inside all our repositories, while hiding away all the implementation details. And this makes it easier to move away from rxdart later on if we wanted to. And before we continue, I want to mention that in implementing this class, we have used various features of the Dart language, which you may or may not be familiar with, such as generics, initializer lists, as well as getters and setters. And if you're not familiar with these language features, you can look them up in the Dart language tour, or even take my Dart course, which covers them in great detail. Okay, so let's continue on the next lesson, where we will use this in-memory store. We are now ready to use our in-memory store inside our fake auth repository. So the first thing to do is to open this file, and then over here we can add a final auth state variable equal to in-memory store, and we can use a nullable app user as the type, and we can pass null as an initial value to the constructor. And of course, in order to use this, we need to import in-memory store. And now that we have this, we can implement the auth state changes method by replacing this code with auth state.stream, like this. And we can also implement this getter variable and simply return authState.value. And next up, it's time to implement the method for signing in and signing out. And before we go ahead, let me make one thing clear, and that is that right now we are implementing a fake auth repository. And what we are not doing is to implement a real authentication system. For this reason, we don't really need to worry about email and password validation. In fact, as far as we are concerned, we don't even need to check the password at all. Because once again, this is a fake auth repository, and we want to make our life as easy as possible. With that in mind, here is a super simple implementation that will be good enough for us. So inside the signing with the email and password method, we can remove this to do, and instead we can type if current user equals to null. And if that's the case, we can write authState.value equals to app user. And for now, we can pass an empty string to the UID, and we can pass the email that was given as an argument to the constructor. But what should we do about the UID? Well, since the UID is something that identifies the currently signed in user, we could at least try to generate a unique value for it that is somehow related to the email. And if we go on pub.dev, we can find a package called UUID that is very well suited for creating unique strings based on various functions. So if we wanted, we could install this as a package and use it over here. But once again, here we are building a fake auth repository, and we can make our life even easier. For example, I think it would be fun if we could generate this UID by reversing the email. And the way to do that is to go on Stack Overflow and figure out how we can reverse a string in Dart. And if we scroll down, we can find this answer that gives us the solution. So let's get back to VS Code, and over here we can replace this with email.split with an empty string as an argument .reversed.join, like this. So once again, this is just one way of doing things. And this is just an implementation detail that doesn't really matter for this repository. In fact, what we are going to do is to copy this entire implementation and paste it inside this method that creates a user with email and password. And one little improvement that we could make at this stage is to move this logic into a separate method so that it is not duplicated. So over here, we can add a new void method called createNewUser, which takes the email as an argument. And then we can go over here and copy these lines and paste them in here. And as a result, we should now be able to delete this code, and instead we can just call the method passing the email as an argument. And we should also be able to do the same inside the signing with email and password method, like this. And finally, we can go ahead and implement the signout method. And this is very easy to do because we just need to set authState.value to null, like this. And finally, there is one last step, and that is that we should call the close method of our in-memory store when we no longer need the fake auth repository. And in order to do that, we can add a void dispose method that we can use to call authState.close, like this. And we should keep in mind that adding this method is not enough unless we also call it in our provider. And the way to do this is to create a final auth variable to hold on to our fake auth repository, and then we can use the ref.dispose callback to call auth.dispose. And finally, we can return auth like this. And this completes the implementation of our fake auth repository. In summary, what we have done in the last few lessons is to implement a fake auth repository that we can use to sign in and sign out the user. And as we can see from how these methods are implemented, this is definitely not something that we would use in production, because the purpose of this repository is just to give us something that we can use to implement the authentication flows in our app without worrying about the backend. And while we had to spend a bit of time to set this up, we now have complete control over our auth repository, and this will make our life easier later on. And as a bonus, we also have an in-memory store that we can reuse in other repositories. And now that our fake auth repository is ready to use, we have completed all the work that we needed to do on the data layer for our authentication feature. And we can move on to focus on the presentation layer in the next lesson. Now that our fake auth repository is ready to go, we can use it to sign in and sign out by calling these methods. And if we explore the authentication feature in our project, we can see that in the presentation folder, we already have an account screen that we can use to log out, as well as an email and password sign-in screen that we can use to sign in or create an account. However, these widgets are currently missing the actual authentication logic. And in fact, all we are doing in the account screen is to pop the navigator when we try to log out. And we have a to-do reminding us that we need to sign out the user. So our next goal is to connect everything together by using the fake auto repository so that we can sign in or sign out and keep track of the user's authentication state with our in-memory store. And we'll also need to update the Home App Bar widget so that it uses the authentication state to build our UI rather than relying on a hard-coded user object as it does now. And out of these three features, I propose that we focus on the sign out logic first, because it is the easiest one to implement, and this will also make for a good introduction to controllers in the presentation layer, which will be based on a Riverpod class known as State Notifier. Okay, so let's get started, and our first step is to update this callback inside the account screen, so that we can sign out the user when we attempt to log out. And by the way, I also want to mention that if we scroll down, we can find this user data table widget that is used to show this data in the middle of the screen. And as we can see, at the moment, we are just hard coding a user value and using it to show this UI. But this is only some temporary code, and what we really want to do is to get the user from our auth repository. So we definitely need to update this code, but we will take care of this in the coming lessons, and our main focus right now is to add the code for signing out in the account screen. And since we need to access our auth repository in order to do this, then we need to convert this widget into a consumer widget that we need to import from the Riverpod package. And as usual, we can add a ref object to the build method. And then in here we can replace this to do, and instead we can type ref.read, and we can pass auth repository provider as an argument, which we also need to import. And once we have this, we can call .signout like this. And one very important thing that I want to point out is that we have not used ref.watch like we have done in many other places, because ref.watch is used when we want to watch some value and rebuild our widget whenever it changes. But here we are inside a button callback, and the purpose of this callback is to do something and not to return a widget. And in this kind of scenario, we had to call ref.read and not ref.watch. And what this will do is to give us an instance of our repository so that we can call some methods on it. And since signout is an async method that returns a future, then we can await for this call to complete, and then we can pop our navigator. And with just one line of code, we have satisfied our requirement to sign out the user when we trigger the logout flow from the UI. However, this code will only handle the happy path, but we also need to think about the loading and error states. In other words, it would be appropriate to check if this call succeeds or throws an error. And we may also want to show some kind of loading UI and disable this button while the signout is in progress. And this entails writing some business logic that doesn't depend on the UI and shouldn't really live on this widget class. And instead, we should find a better place for it, and that would be inside a controller class, because this will give us a better separation of concerns between business logic and UI code, which is a concept that we will continue to explore as we make progress. So for now, we can add a to-do in here to remind us to only pop if this call succeeds, and then we can continue on the next lesson. In this lesson, we're going to create our first controller class, which is a class that belongs to the presentation layer. And since controller is quite a generic term, I think it's useful if we define more clearly what is its purpose in relation to our app architecture. And that is to manage the widget state and mediate between the widgets and all the remaining layers. And depending on what terminology we use, controllers are broadly similar to view models in the MVVM architecture and to blocks in the block architecture. And since we are using Riverpod, all our controllers will be based on a specific class called State Notifier, which is very similar to the built-in Value Notifier and Change Notifier classes in the Flutter SDK. And if you worked with Flutter Block before, you'll find that State Notifier is also very similar to a qubit, which is a simplified version of Block. And by the way, I should mention that with the release of Riverpod version 2.0, a new Async Notifier class has been introduced as an alternative to State Notifier. And if you go to this page on my website, you can find an in-depth article about the differences between State Notifier and Async Notifier. And just to be clear, in the next sections of the course, we will use State Notifier, which is still fully supported by Riverpod. And I'll cover Async Notifier more in detail on section 13, which will be all about the new APIs that were added to Riverpod 2.0. Okay, so let's get back to VS Code and see how to use State Notifier in practice. And what we want to do is to locate the account folder. And inside here, we can create a new file called account-screen-controller.dart. And inside here, we can create a class account-screen-controller which extends state notifier, which is a class that we need to import from the Riverpod package. And if we hover to reveal the documentation, we can read that state notifier is an observable class that stores a single immutable state, which works as a replacement for change notifier or block. And as we can see, this class needs a type, which in this case will represent the state of our widget. And this state can either be data, loading, or error. And since we have already learned that a sync value helps us with that, then here we can use a sync value of type void without having to create a new type specifically for this controller. And then we need to add a constructor to this class. And one thing to notice about state notifier is that it needs an initial value. So let's add a constructor and use an initializer list to call super and give it an initial value, which will be an async value of type void dot data, passing null as an argument. And the reason I'm using void with a value of null is that in this case we don't really have a value as such, and as we will see, the only thing that we care about is to distinguish between data, loading, and error. Next up, we can create a method that we can use to sign out. So let's create a method that returns a feature of type void, and we can call this sign out and add the async keyword. And then inside here, there are 4 things that we want to do. The first one is to set the state to loading. The second one is to sign out using our auto repository. And in case of success, we want to set the state to data. And in case of error, we want to set the state to error. And since we need to use the auto repository in order to sign out, then this should be a dependency for our controller. So for this reason, over here, we can add a final fake auto repository, which we need to import. And inside the constructor, we can add curly braces and add it as a required argument, like this. And now we are ready to implement the signout method by following these steps. So as a first step, we can set the state to a sync value of type void dot. And as you can see, here we can choose between these 3 factory constructors. So in this case, we can use loading, like this. Then we should await for auth repository.sign out, like this. And after this, we can set the state again to handle the happy path. And we can do this by setting our state to a sync value of type void. And this time we can choose data and pass a value of null. And the last thing that we want to do is to handle the error state, which is something that happens if this method in the repository throws an exception for any reason. And as you know, in Dart, we can handle exceptions inside a try-catch block. So here we can type try and use this snippet to autocomplete it. And then we can select these 3 lines and move them inside the try block. And then inside the catch block, we can type state equal to async value dot void. And this time we can choose dot error, passing it as an argument. And by the way, I should point out that since Riverpod 2.0, async value dot error takes a second argument, which represents the stack trace. So if we want our code to compile, then we need to get the stack trace from here and pass it as an argument over here, like this. And this completes the implementation of the signout method. And one thing that I want to point out is that here we are setting the state variable multiple times. And as we will see, we'll be able to watch this state in the account screen widget and make sure that it rebuilds every time it changes, using the same Riverpod APIs that we're already familiar with. But for now, let's stay on track. And now that we've created our account screen controller, we also need to create a provider that we can use to access it. So if we scroll down over here, we can start typing state notifier, and we can choose this state notifier provider option, because state notifier is the parent class of our controller, and we can call this account screen controller provider. And then we need to specify 2 type annotation, and the first one is our account screen controller class. And the second one is the type of the state class itself, which in our case is a sync value of type void. And then inside the body of the provider, we can remove this code, and instead we can declare a final auth repository equal to ref.watch with auth repository provider, so that we can return an account screen controller, passing it as an argument, like this. And finally, there is one last thing to do, and that is to add the auto dispose modifier, as this will ensure that our controller is disposed when it's no longer needed. And since this is a state notifier provider, then Riverpod already knows how to dispose this without having to specify a ref.onDispose callback explicitly. So this completes the implementation of our account screen controller and the corresponding provider. So over here we can remove these comments as we no longer need them, and the main takeaway from this lesson is that state notifier is an alternative to the value notifier class in the Flutter SDK, and we can use it whenever we want to define some immutable state that our widgets can listen to. And we can do that by defining the type of our state class in the class definition itself. And just for reference, let me show you another controller class that is equivalent to this, but uses change notifier instead, which is something that you may have used before. And as you can see, when you use change notifier, you define one or more mutable state variables which are not declared as final. And when you modify these variables, you had to remember to call notify listeners, and this is quite error prone. And the other drawback of this is that since state is mutable, then any widget that has access to the change notifier could potentially modify its state. And we definitely don't want this to be possible, because our widgets should only read the state and not modify it directly. So let me go ahead and remove this. And in any case, we will continue to talk about state notifier and the advantage of immutability as we make progress. Okay, so let's continue on the next lesson, where we will see how to use our controller. Now that our account screen controller is ready, we can get back to our account screen and see how to use it. And as part of this, there are three things that we need to address. First, we want to use the account screen controller to sign out rather than using the auth repository. Second, we need to keep track of the loading state so that we can disable the logout button while sign out is in progress. And third, we need some way of dealing with errors so that we can show an alert if the sign out fails. So let's start with the first step. And what we need to do here is to replace this auth repository provider with account screen controller provider and make sure that we import it. However, once we do this, we get an error telling us that the method signout isn't defined for the type async value, and that we should try to correct the name to the name of an existing method or defining a method named signout. And the reason we get this error is that by reading or watching a state notifier provider, the value that we get is not the state notifier subclass, but instead is the state class itself, which in this case is an async value of type void. And of course, async value doesn't have a signout method. So what we had to do instead is to read account screen controller provider.notifier, as this will give us access to the account screen controller so that we can call signout on it. And of course, by calling this method, then we are executing all this code which sets the state and calls the signout method on the auth repository. And this means that we can now watch state changes in our widget. So let's move over to the top of the build method. And over here, we can type final state equals to ref.watch account screen controller provider. And as we can see, this state variable has type async value of type void, which is what we expect. And this means that if we want, we can call state.when and return different widgets based on this state. However, in this case, the layout of this page doesn't need to change depending on the state, like we have done on the products grid by showing a circular progress indicator until all the data is loaded. Instead, in this case, I propose that we use the state in a more subtle way. So let me remove this line. And over here, we could disable this callback if the state is loading by using the ternary operator like this. And if we really wanted to show a circular progress indicator, then this should be something subtle that appears somewhere on this page without changing the entire UI. For example, we could modify the title of this app bar by showing a circular progress indicator if the state is loading, or show the regular text otherwise, like this. And we'll keep this change for the next few lessons so that we can get some visual feedback about the loading state. Though don't show this UI to a designer, as this is not a great place to put a circular progress indicator. In any case, the most important thing is that we understand how this new code works. And the idea here is that by creating a state notifier subclass, we have been able to add some simple business logic to control the state of our widget and take care of communicating with the underlying repository so that our widget doesn't have to do this directly. In fact, I would suggest that whenever you have a UI callback that is used to modify some application state, then the code for managing this should not live on the widget itself, and instead it's better to create a separate controller for this. And then in the widget, you can watch the state like you would do if you were reading any other provider. And inside your callback, you can use ref.read to call any of the methods in your controller. And this should start to give you an idea about what is the purpose of the controllers in the presentation layer. And as we will see in the next section, we can easily test controllers by writing unit tests rather than widget tests, because they don't depend on the UI. So let's continue on the next lesson, where we will learn how to handle error states using listeners. In this lesson, we are going to learn how to use ref.listen, which is a useful Riverpod API that we can use to show a message to the user in response to a given state change. And as we have seen, if our authentication repository throws an exception, then we can catch it inside our controller and set the state to async value.error. But up until now, we haven't really made use of this in the account screen. And this bears the question, how should we handle errors in the UI? Should we rebuild our screen and show some text message inside it? Or should we present a snack bar or an alert dialog? Well, if we just wanted to show a text message inside this page, then our job would be quite easy, because we could just write if state.hasError, and then we can use this to conditionally return a text widget with an error inside it. However, this would not lead to a good user experience, and I think it would be better and also more interesting if we can figure out how to present a snack bar or an alert dialog. And one way to do this is by using a provider listener. So let me remove this code, and then I can show you how this works. And the idea is that at the top of the build method, we can write ref.listen, and then we need to specify a type. And in our case, this is async value of void, because this is the type of our widget state. And then we need to pass two arguments. And the first one is the provider that we want to listen to. And the second one is a function that gives us the previous state and the current state as arguments. And if we want, inside here, we can use one of the pattern matching arguments of the async value class, such as when data, when or null, or maybe when. And if you want to learn more about these methods, then make sure to check them out in the documentation. But in this case, I think a better alternative is to check if our state has an error. And in this case, we can call showExceptionAlertDialog, which is a helper function that I've included in the starter project. And this function takes three arguments. The first one is the context. The second one is a title that we can set to error.hardcoded. And finally, we need to pass an exception and give it state.error as an argument. And as we will see shortly, this code will show an alert dialog that we had to dismiss. Though if you wanted to show a snack bar instead, you could do so by writing some code that uses a scaffold messenger like this. But in this case, I think an alert dialog is best, because it requires the user to dismiss it explicitly. So I'm going to remove this code. And now that we have this, I want to show you that it works. And a simple way of testing both the loading and error states is to go back to our fake auth repository. And then inside the signout method, we can await for a future delayed with a duration of 3 seconds. And we can also throw an exception that says connection failed, for example. And then we can hot reload. And if we try to log out now, then we can see that the circular progress indicator appears while the state is loading. However, the alert dialog does not seem to appear. And the reason for that is that even though we call showExceptionAlertDialog inside our widget, the first thing that happens as soon as we sign out is that we call navigator.context.pop. And this causes our alert dialog to be dismissed immediately before we even get a chance to see it. And in fact, this to-do is here for a reason, because we should only call navigator.pop if our call is successful. So for the time being, let's comment out this line and we'll come back to it later. And then we can save and try again. However, one thing that you may notice is that if we try to log out one more time, then the error appears immediately, and then one more time after the 3 seconds delay. So it looks like something is not right, because we would expect to get a loading state without an error as soon as we try to log out. So the problem is that we have an error alert that appears immediately, despite the 3-second delay that we have added inside our repository. And the reason this is happening is that when we set the state to loading inside our controller, then Riverpod is doing something clever under the hood, and it still holds some information from the previous state so that we can access it if we want. And since the previous state was error in this case, then inside our widget, we get a callback when the state changes. And here we show an alert dialog because this condition is true even when the state is loading. And the way to fix this is by checking a particular property called isLoading and only run this code if isLoading is false. And now that we have made this change, we can hot reload, and we can see that when we try to log out, then nothing happens right away. And the alert dialog only appears after 3 seconds, because at that point we have reset the state to error and we are no longer refreshing. And if all of this seems quite confusing, you have all my sympathy, because I was also very confused when I first encountered this issue. And I should mention that all of this is due to a breaking change that was added to Riverpod version 2.0. And as I record this lesson, the only place where this is documented is in the changelog, which says that after a provider has emitted an async value.data or error, that provider will no longer emit an async value.loading. Instead, it will re-emit the latest value, but with the property of async value is refreshing set to true. And the reason for this change is that this allows the UI to keep showing the previous data or error when a provider is being refreshed. So as it turns out, this behavior is actually quite useful when we are trying to refresh our data. And the only problem is that as I record this, it is not covered in the documentation, which only has an empty page about it. Okay, so let's do a wrap up. And in summary, in this lesson, we have learned to use the ref.listen method to respond to error states. And we have seen that this gives us a callback that we can use to run some code, such as showing a snack bar or an alert dialog. And I think this is a good time to compare ref.watch, ref.read, and ref.listen so that we can understand when to use them. And as we can see, inside the build method, we should always use ref.watch to watch state changes and rebuild our widget as a result. But inside callbacks, we should use ref.read instead to access a provider and call some methods on it. And if we want to listen to state changes without rebuilding, then ref.listen is our friend. And we should also be aware that when we use ref.listen, we also need to check if our provider is refreshing if we intend to show some error UI. And if this all sounds a bit new and unfamiliar, don't worry, because we'll continue using these methods as we make progress and we'll soon get used to them. And by the way, if you want to get a better understanding of what things you should and shouldn't do inside the build method, I recommend that you read this article about side effects in Flutter. Okay, so let's continue on the next lesson. In this lesson, I want to take care of one small detail that we have left out when implementing the sign out code in our widget. And that is that we should only pop the navigator if this call to sign out has succeeded. So how can we do that? Well, one way to do this would be to modify the signout method to return a boolean value, which is true if the signout succeeds or false otherwise. So let's do that and change the return type to future of type bool. And then on success, we can return true. And if we get an exception, we can return false, like this. And now that we have made this change, we can get back to our widget. And here we can type final success equals await ref.read and call the signout method. And here we can remove this to do and type if success. And only if this is true, then we can call navigator of context.pop. And now we can verify this and try to log out. And we should be able to see that the page is not dismissed if we get an error. So if I click OK here, then I can see that I remain on the account screen. And then we can get back to our fake auth repository. And here we can comment out this line and revert to the default behavior. And then we can test this again and trigger the logout flow. And as we can see, in this case, the page is dismissed because our call succeeds and success is true. And one question that you may have at this stage is, what about separation of concerns? Because what we have said before is that it is best to move our business logic inside our account screen controller class. However, we now have two conditions inside this callback that lives inside the widget class. So shouldn't this logic also go inside the controller? And this is something that developers often disagree about. And what I will say in this regard is that the code for showing the alert dialog and popping the navigation stack depends on the build context. And my take on this is that controllers should never depend on the build context or anything to do with the UI. And for this reason, I'm choosing to leave this logic inside the widget. However, I also recognize that we have more logic than we would like in here. And one possible way of dealing with this is to pass some function arguments to the signout method so that we can implement some of this control flow inside the controller while leaving all the code that depends on the context inside our widget. However, for now, I'm just going to keep things simple. And in any case, later on in this section, we will figure out a way to remove this navigation code and use GoRouter to modify the navigation stack when the authentication state changes. So for now, we're going to keep this code as it is, and we can continue on the next lesson where I'll share a cool little trick about async value. Now that our account signout feature works as expected, I want to clean up our code a little bit and share an interesting tip with you. So if we open the signout method inside our controller, we can see that here we use this try and catch block to handle both success and error states. And this is the kind of code that we would have to write over and over when we create new controllers. So it would be good if we could simplify this a little bit and maybe even find an alternative to using try and catch. So let's open the definition of the async value class and see if we can find something useful. And if we scroll down past these factory constructors, we can find this method called guard. And this is a static method that takes a function that returns a future as an argument. And then it awaits for that future and returns the value inside async value.data. And also wraps this inside a try and catch block and returns a sync value.error if the future throws an exception. So this looks very handy and we can use it to simplify our code. So let's get back to our account screen controller. And let me show you how to implement the signout method using guard, and we'll keep the old code inside a comment for reference. And as we implement this, then the first line is the same, because we always need to set the state to loading. But then things get interesting, because we can type state equals to await async value.guard, and here we need to pass a function argument. So we can use the arrow notation to return old repository.signout. And what is great about this is that this state will contain data or error depending on whether this feature succeeds or not. And now we have only one thing to do, and that is to return a Boolean value. And this should be true if state.hasError is false, like this. And as you can see, this implementation only takes 3 lines of code. And it means that we no longer had to write this try and catch block explicitly. So I hope that you've enjoyed this little trick, which you can also find on my website at this page. So if you want, feel free to use guard in your own apps. Okay, so let's continue on the next lesson. In this lesson, I want to introduce a useful extension method that we can use to reuse some logic. And if we go back to the account screen, we can see that over here we added this code to ref.listen that we use to show an alert dialog if we have an error state. And this is the kind of logic that we should be able to reuse as we handle errors in other screens as well. So what I propose we do is to create an extension method on async value that will contain all this logic. And a good place for this is inside the utils folder. So over here we can add a new file called async value UI.dart. And inside here we can type extension async value UI on async value. And inside this extension, we can add a method that returns void, and it's called show alert dialog on error, and this should take a build context as an argument. And in order to use this, we need to import Flutter Riverpod, as well as material.dart. And then we can get back to our account screen. And here we can copy all these lines and get back to our extension, and then we can paste them in here. And as you can see, we now get some errors because state is not defined. But in fact, we don't need to use state dot at all because we are inside an extension of a sync value. And this means that we can access all these properties directly. So let's remove state dot from here and here and here. And then we can make sure to add all the necessary imports, like this. And just to be clear, since Riverpod 2.0, the correct property to check here is not isRefreshing, but we should use isLoading instead, like this. And now that we have created this extension, we can copy the method name and we can get back to our account screen. And here we can replace this entire function by using the arrow notation and calling state.showAlertDialog on error, passing the context as an argument, like this. And of course, we need to import the file that defines our extension, like this. And we can also replace this previous state with an underscore, since we are not using it. And as a result, we can now listen to errors and show an alert dialog in just a few lines of code. And we can do this in a consistent way across all our widgets. And now we can save our file. And before we continue, I want to point out one small detail, and that is that inside our controller, we are repeating async value.void over and over in different places. And in general, it's a good idea to add type annotations like this in Dart, because the compiler can warn us if we make a mistake. For example, if we change this type to int, then we get an error telling us that a value of type null can't be assigned to a parameter of type int. However, I feel that it's a bit verbose to type async value of type void over and over in this controller. And I think it's okay if we drop the void type annotation in this case, as this will make our code more readable. And an easy way to do this is to select async value of type void, and then we can use search and replace all instances of this with just async value, like this. And then we can save this file. And if we go back to our account screen, we can also remove it from here in this code to ref.listen. And once again, the important thing is that we understand what is the role of type annotations and use them if they make our code safer. But there are some cases where I think it's okay to do away with them, like in this example. Okay, so let's continue in the next lesson. Now that we have completed the logout functionality for signing out of the app, we can focus on the remaining parts of the authentication flows. And this means that we need to add the logic for signing in, as well as making sure that the main app bar shows the correct actions based on the authentication state of the user. So let's focus on the app bar first, and then we'll take care of the email and password signing form. And if we open the home app bar widget, we can see that at the moment this user variable is hard-coded inside the build method, and this is used to decide which options to show over here. And what we want to do instead is to open our fake auth repository and use this auth state changes provider instead, because this gives us a stream that emits a new value every time the authentication state changes. And in order to use this provider, then we need to turn our home app bar into a consumer widget, and also add a widget ref to our build method, and we need to import Flutter Riverpod in order to use this. And now that we have this, we can delete these two lines, and instead we can type final user equals to ref.watch auth state changes provider, which we need to import. And as we can see, down here we now get an error because we can no longer use this const keyword since our user is not a constant value. So let's remove this and save. And the other thing that I want to point out is that ref.watch gives us an async value. And this means that we could use the when method to provide data loading and error callbacks. But one thing that you should know is that you can also type .value, and this will give you a nullable variable that will always be null if the state of the async value object is loading or error. And this works quite well in this specific case because it means that we'll get a non-null user only when we are signed in and null in any other case. So at this point we can save our file. And as we can see, the previous orders and account options have disappeared. And instead, we only get an option to sign in. And the reason for that is that in the fake auth repository, the initial authentication state is null. And this means that our home app bar is now doing the right thing. And while we have only changed a couple of lines of code, the significance of this is that every time the authentication state changes, then our home app bar will rebuild. And as we will see, as soon as we are able to sign in with email and password, then this widget will automatically update to show the correct actions. And before we continue, we should also get back to our account screen. And if you remember, earlier on in this section, we have said that we also need to update this user data table widget, as currently we are still using a hard-coded value in here. So just like we have done before, we can also convert this widget to a consumer widget and add a widget ref argument to the build method. And just like we have done in the home app bar, we can remove these two lines from here, and then we can get back to the home app bar, and here we can copy this line from here and paste it back in here. And we can also import our auth state changes provider. And if we scroll down, we see that here we get a couple of errors. And these are telling us that the property UID can't be unconditionally accessed because the receiver can't be null. And this makes sense because the user is now a nullable object. And we need to make sure that we use the conditional access operator and provide a fallback value when we pass the user and email arguments to this method, because this takes a non-nullable string argument. In any case, these are just small details and we don't care too much about what we show inside this user data table. However, what is more relevant is that we have discovered new ways of reading the value of an async value. In fact, sometimes it's good enough to read the value as a nullable property, like we have done in this case. And then we can use some conditional logic inside our layout code to decide which widgets to show based on this value. But as we have seen in the previous section, when we have introduced the async value widget, sometimes we need to completely change the UI that we present to the user depending on whether we have data, error, or a loading state. And in that case, it makes more sense to use the when method to handle each case differently. So at the end of the day, it's up to you to decide what to do when you need to use an async value inside your widget. And if you want to learn more about async value, you can open its definition and read about all its methods and properties. And as you can see, here you can find useful getters such as isLoading, hasValue, value, error stack trace. And there are also some other methods that we haven't covered yet. And in addition to this, we also have the guard method, which we have discovered in the previous lessons. So the bottom line is that async value is quite versatile, and by learning how to use it, you can save yourself a lot of extra code. And one great thing about Riverpod is that when you watch a feature provider or a stream provider inside your widgets, you always get an async value, which is quite convenient. And as we have discovered, you can also create your own custom state notifiers, which are based on async value. And this means that once you learn how to use this properly, then you'll get a lot of value out of it. And in fact, we'll continue to use async value extensively in this course. Okay, so let's continue in the next lesson. In this lesson, I'm going to give you an introduction to the email and password sign-in screen, which is the last screen that we need to complete in order to have a functional authentication flow. And you can find all the code for this screen inside the sign-in folder, which lives in the presentation layer of our authentication feature. And if you open the email and password sign-in screen, you'll find that this is a relatively complex file that has nearly 200 lines of code. And this is because it includes code to deal with things such as form validation, text field customization, as well as the logic for updating the input focus as we fill the email and password fields. And also, this is a configurable widget that we can use to toggle between two different modes for signing in and creating an account. And if you've ever tried to implement an email and password signing form yourself, you'll know that all these little details add up. So it's not really surprising that there is so much code in this file. And aside from this, I've also included a separate class called email password signing state. And this lives inside a file that contains other things that are needed by this page, including the definition of the email password signing form type that we can use to toggle between two different modes, as well as a mixing that contains some email and password validators. And these are defined with some helper classes that I've declared inside this file. And these classes use some regular expressions under the hood, which are used to perform client-side validation. And just to give you an idea about how this code is used, we can see that if we try to submit this form, then we get some errors telling us that the email and password can't be empty. And if we try to type in a string that does not represent an email address, then we get an invalid email error instead. And this is all made possible by some of the regex validators that I've defined over here. And if we get back to the previous file, we can see that I've added this email and password signing state class. And the purpose of this is to keep track of the current form type, as well as the loading state that we will use to show a circular progress indicator when we attempt to sign in. And we will look at this file more in detail shortly, but for now the main takeaway is that all this code is a starting point that we can use to add the missing authentication logic. In fact, if we head back to the sign-in screen and scroll down to the submit method, then here we can find this to-do, which tells us to add the authentication logic. So our goal in the next few lessons is to implement a controller class that we can use to sign in or create an account. And just like we have done with the account page, our controller will mediate between our widget class and the authentication repository. And it will also take care of setting the widget state. And if we scroll up, we can see that the state is declared as a state variable of type email password signing state. And the main idea behind this class is that whenever any of these fields changes, then we should rebuild our widget. And in fact, if we want, we can use the search tool to find instances of set state. And as we can see on line 106, we update this state variable by calling the copyWidth method with the new form type. And this happens inside a method that is called when we click on this button. And if we scroll down and take a look at the build method, we can see that we use this state variable in many different places. And in addition to the isLoading and form type properties, I've also defined an extension on this class. And this contains many additional getters and helper methods that help us to keep our widget code a bit more tidy. And chances are that if you deal with complex forms, you're likely to end up with multiple state variables, and by moving some of your state and logic into separate classes, then your code will be better organized and more testable as well. And if we go back to our widget class, I also want to point out a couple of small details. And the first one is that while I've created this state class to hold the form type and isLoading variables, then this does not contain the email and password themselves, because these can be derived directly from these text editing controllers. And we don't need to rebuild the entire widget when these values change. And you can see that I've also defined this standalone submitted variable as well. So when it comes to deciding how to group various state variables and whether they should belong to the widget class or a separate state class, there isn't really a single solution that will work well for all cases. And in fact, if you wanted to build your own email and password signing form from scratch, chances are that you would end up with a different implementation. So for now, the bottom line is that you don't need to worry too much about all the existing code, and my goal over the coming lessons is to show you how to complete the implementation of this page by borrowing some ideas from the account screen and account screen controller classes that we have implemented recently. And by doing this, we'll get a better idea about how everything fits together when dealing with a more complex page that requires some user input. Okay, so let's continue on the next lesson. We are nearly ready to add a controller class that we can use to sign in or create an account and manage the state of our widget class. And if you remember, when we did this in our account screen controller, we extended state notifier using a sync value as a state class. And then we used the signout method to set the state as needed while calling the signout method of the auth repository. And as far as our email and password signing screen goes, we want to follow the same approach and also create a controller that can manage the state rather than storing this as a local state variable. However, the state class that we are going to use is not a sync value, and instead we want to use this email password signing state class, because this contains the two properties that are needed by our widget class. And before we go ahead and create our controller, I want to talk about this class a bit more in detail. And if we look a bit closer, we can see that in addition to these properties, this class also has a copy with method. And it also has some overrides, including the toString method, the equality operator, and the hash code getter that come from the base object class. And if you ever end up creating your own custom data or state classes, it's likely that you'll also need the same methods. And the quickest way to generate these methods is by using the Dart data class generator extension. And I recommend that you install this if you don't have it already. And just to show you how this works, over here I can delete all these methods, like this. And then if I select any of these properties, I can use the quick fix option to generate all the methods in the data class. Or alternatively, I can choose only the ones that I want, such as copy with, toString, and equality. And for the record, there are also other ways of creating data classes in Dart, and some of them rely on code generation tools. However, for creating simple data classes, I find that the Dart data class generator is the simplest and quickest solution. In any case, the most important thing about creating custom state classes is that they should be immutable. And we can accomplish this by declaring all the properties as final. So once again, when you create state classes, I highly recommend that you make all the properties final by default. And this is particularly important so that you don't modify their values by mistake in your widgets. In fact, if we follow this architecture, then widgets should only watch state changes as read-only value and should never be allowed to modify them. And instead, it is the job of the controllers to update the state. And as we will see in practice, the only way to update these properties is to use the copy with method, which will create a clone of our object and only update the values that are given as arguments. And what's also very important is that you always add the equality and hash code implementations, because many state management packages such as Riverpod, Block, and Redux rely on this in order to know if two instances of this class are the same. And we will talk more about this in the next section about testing. Okay, so let's continue on the next lesson where I want to make an important change to this class. As we have seen, our email password signing state class contains a boolean isLoading property that tells us if we are in the process of signing in or not. But as we have discovered, it's better to use a sync value for this because this carries more information about data, loading, and error states. So what we are going to do in this lesson is to update this property to become an async value, and we are going to change its name as well. And before we do that, we can remove all these methods, since we can easily generate them again after we update our property. And then we are going to change the type of this property from bool to async value of type void, and we need to import Flutter Riverpod in order to use this. And we are going to call it value instead. And then in a constructor, we can update the name of this argument and give it a default value of const async value.data with null as an argument. And now that we have updated this, we can select our property and then use the quick fix to add the copy with, toString, and equality operators. And then we can save our file. However, if we go back to our widget class and scroll down to the build method, we can see that we have a few errors. because we no longer have a property called isLoading inside our state class. And we have the same problem in multiple places. And rather than refactoring all this code, what I propose we do is to go back to our email password signing state class. And here we can add a boolean getter variable called isLoading, which should just return value.isLoading. And if we save this, we can see that this will make all the errors go away inside our widget class. And in fact, we have only one error left. Because when we declare our state over here, we are trying to pass a constructor argument that no longer exists. And all we had to do to fix this is to remove this argument, since we already have a default value for this. And since we changed the definition of the state class, I think it's best if we hot restart our application. And then we should be able to go back to the signing page, and we should be able to use this page without getting any errors. In summary, what we have done is to update the email password signing state class to store an async value alongside this form type. So let's continue on the next lesson, where we'll create a controller class that can use this. Now that our email and password signing state class is ready to use, we can go ahead and create our controller class. So inside the signing folder, we can create a new file and call it email and password signing controller.dart. And here we can add a class email password signing controller, and this should extend state notifier, and we can pass email and password signing state as a type annotation. And in order to use this, we need to import Flutter Riverpod as well as our state class. And then we need to add a constructor, since we are extending state notifier. And then we need to use the initializer list to call super and pass an initial value for our email and password signing state. And this takes form type and value arguments. And as we can see, both these arguments have default values, so we can omit them if we want. However, suppose that we want to choose which form type to use when we present this page. For example, if we present the page from here, then we want to show the signing form. But if we open the shopping cart and choose the checkout option, then we want to show the registration form instead. So in order to choose which form type to use when we show this page, then we can add a required email password signing form type to our constructor, and then we can pass it along to our email password signing state, like this. And the important thing to remember here is that whenever you extend a state notifier, you always need to provide an initial value. And you can do so by defining default values in the constructor of your state class, or adding them explicitly in your controller's constructor, so that you can use them in the initializer list. Next up, let's add a final fake auth repository, since we will use this shortly. And let's also set it in the constructor, like this. And of course, we need to import it if we want to use it. Next up, we need to implement a submit method that we can use to sign in or create an account. And like we have done with the account screen, this should return a feature of type bool, and we can call it submit, and this should take the email and password as arguments. And we should also mark this as async. And then inside the method body, we need to set the loading state. And since our state has type email and password signing state, then we need to use the copyWith method to do this. So over here we can type state equals to state.copyWith, and we can pass a value of async value.loading, like this. And this will keep the existing form type and only change the value. And if you remember, what we said before is that this state object is immutable, meaning that its properties cannot change. And as we can see, the way to update the state in the controller is to call copyWith and return a new state object that we can assign like this, rather than modifying the existing one. Next up, we need to call the correct method from the auth repository so that we can sign in or create an account based on the form type. And since this will require some conditional logic, I propose that we implement a separate method that returns a feature of type void, and we can call this authenticate, and this will take the email and password as arguments. And then inside it, we can add a switch statement on state.formType. And if the form type is signing, then we can return authRepository.signing with email and password, passing these two arguments. And if the form type is register, then we can return authRepository.createUser with email and password, and pass these arguments as well. And now that we have this method, then over here we can type final value equals to await, and like we have done before, we can use async value.guard and pass a function argument that calls the authenticate method that we have just created, like this. And the result of this expression will be an async value that will contain either data or error. And we can use this to update our state by calling copyWith, passing this value as an argument. And finally, we can return value.hasError equals to false to tell the calling code if the authentication was successful or not. And this completes the implementation of our submit method. Next up, we also want to implement a method that we can use to update the form type, as this is something that we will call from our widget class when we press this button. So over here, we can add a new void update form type method, which takes an email and password signing form type as an argument. And then inside it, we can type state equals to state.copyWith and pass the new form type, like this. And this is all the code that we needed to add to create our controller class. And the last thing that we need to do is to create a provider that we will use to access this controller. So let's create a state notifier provider. And we can call this email password signing controller provider. And then over here, we need to pass email password signing controller and email password signing state as type annotations. And we can also pass the auto dispose notifier to make sure that we dispose our controller when we no longer need it. And then inside here, we can remove this return statement. And we can type final auto repository equals to ref.watch with auto repository provider. And we can return an email and password signing controller, passing the auto repository as an argument. But as we can see, we now have a problem because this constructor takes a form type, but we don't have access to it inside this provider. However, we already know that we can solve this kind of problem by using the family modifier. So we can add it over here. And the thing to remember about family is that when we use it, we always need to add an additional type annotation, which in this case is email and password signing form type. And as a result, we also get a form type argument over here that we can pass to our email password signing controller, like this. And this completes the implementation of our controller along with the corresponding provider. And as you can see, all this logic is much more complex than the account screen controller that we created earlier on. Because this time we are dealing with more complex state, and we even have some conditional logic to decide which authentication method we need to call. And there should be no doubt that adding this logic inside a separate controller class is better than keeping it inside our widget. And as we will see in the next section, this code is also much easier to test. Okay, so let's continue on the next lesson where we will use this controller. Now that our controller class is ready, we can use it in our widget class. So let's open the email password signing screen widget. And if we scroll down, we can find this email and password signing contents widget, which is the one that we want to update. And the first thing that we need to do is to convert this class to a consumer stateful widget, which is a class that we need to import from Flutter Riverpod. And this is equivalent to the consumer widget class that we have used before. And as part of this, we also need to update the state class to consumer state over here and over here as well. And now that we have this, we can access our provider by using a ref object. So let's scroll down to the submit method. And over here, we can remove this to do. And instead, we can type final controller equals to ref.read. And we can pass email password signing controller provider .notifier as an argument. And in order to use this, we need to import it. But as we can see, we now get an error telling us that the getter notifier isn't defined for the type autodispose state notifier provider family. And family is the thing that we should pay attention to, because we need to remember that this is a family provider. And this means that we need to pass a form type argument. And we can pass this as an argument over here. And the value that we need to pass is widget.formType, because this is given as an argument in the corresponding widget class over here. So let's get back to our signing method. And now that we have our controller, we can use it to submit the email and password and type final success equals to await controller.submit, passing the email and password, which are defined as getter variables over here. And then we can type if success. And if this is true, then we should call our widget signing callback. And just to be clear, this callback is defined over here inside the corresponding widget class. And in turn, this is passed as an argument by the parent widget class, and it is used to call navigator.pop to dismiss the page. So the outcome of all of this is that if we call this callback over here, then the page will be dismissed if authentication is successful. So as you can see, these few lines of code take care of all the authentication logic for us. And it's easy to see that if we didn't have a controller, then this method would have been a lot longer. And at this stage, you may be wondering if this form validation logic should also not live inside the controller itself. However, I would argue that both this global key and the form state are classes that belong to the Flutter SDK itself. And I prefer for my controllers to be pure and not have any dependency on Flutter. And as long as we can manage to keep anything that does not depend on the UI inside the controllers, then I think it's okay if we have a little bit of conditional logic in the widgets. And overall, I think what we ended up with is fairly reasonable. But our job is not done yet, because we still need to remove the state variable from here, because our goal is to read the state from the controller instead. So let's remove this line, and if we scroll down, we can see that now we have a few errors, and we are going to fix them one by one. And the first thing that I want to do is to fix this update form type method. So over here we can remove this call to set state, and instead we can type ref.read, passing the email password signing controller provider as an argument. And we need to remember that this is a family, so we need to pass widget.formType as an argument and call .notifier, because we want to access the controller and not the corresponding state class. And now that we have this, we can call update form type, passing form type as an argument. And then we can move over to the build method, where we can also find a bunch of errors. And the first thing that we need to do at the top is to type final state equals to ref.watch email password signing controller provider, passing widget.formType as an argument. And now we can use find and replace on this file to replace all instances of underscore state with state, because this was the name of the old state variable, and this is the new one that we declared inside the build method. And before we go ahead and replace all instances, let's also make sure to enable this match whole word option, so that we don't replace longer words that contain underscore state inside them. Okay, so let's go ahead and apply this change. And if everything works correctly, then you should see that all the compiler errors have now gone. So we can save our file. And as you can see, we now get an exception inside this consumer state class, which belongs to the Riverpod package. And that's because we have changed the parent type of our widget class. So what I propose we do is to hot restart the application. And now we should be able to open the sign-in page and get back to our widget class. And by the way, let me just say that since the previous refactoring step was not easy, I'll share a completed code snapshot at the end of this lesson, so that you can get back on track if something is not working for you. But before we wrap up, there is one thing left to do, and that is to show an alert if there are any errors. And we can do this at the top of the build method by typing ref.listen, passing email password signing state as a type annotation, and then we can pass the email and password signing controller provider with widget.formType as an argument. And then we need to specify a function that gives us the previous state and the current state. And we can use this to call state.value.showAlert dialog on error, passing the build context as an argument. And of course, in order to use this, we need to import our async value extension. And just to be clear, the reason this works is that this value property of the state class is an async value. And for this reason, we can call this extension method on it. And this completes the implementation of the email and password signing flow. And this means that we can go ahead and test all the new functionality. So as a first step, we can open this page. And as we can see, if we select this secondary button, then we can toggle between the two different form types. And this confirms that the update form type method inside the controller is called. And since we use this to update the state, then our widget rebuilds as a result. And we can also try to submit the form when the email and password are empty. And when we do this, we get these error hints in red text. And this confirms that the client validation code works as expected. But the most interesting part is around the authentication logic. So if we enter a valid email and password and try to sign in or create an account, then we can see that we are taken back to the home screen. And we can see from these actions at the top that the authentication state has changed. And from here, we can open the account page and sign out again. And then we can get back to the sign-in screen. And the last thing that we need to do is to test that the loading and error states work as well. And to do that, we can open the fake auth repository and modify the implementation of this method. For example, we could copy these two lines from here and paste them in here and remove this content to make sure that we add a delay and throw an exception. And then we can save and hot reload. And if we try to enter a valid email along with the password and we try to sign in, we can see that now we get a loading indicator, and this is followed by an error alert, and this confirms that everything works as intended. Or I should say, almost works as intended, because there is a small bug that we need to address, and I'm going to tell you all about it in the next lesson. In the previous lesson, I told you that there is a small bug that we need to address. So let me reproduce this for you, and then we can try to fix it. And as we have seen, at the moment, this method to sign in with email and password throws an exception after a small delay. And as a result, we get this error alert after we try to sign in. So this is what we expect. However, if we now press this button to toggle the form type, then this error alert appears again. So what is going on? Well, to understand this better, let me open the async value UI extension method called show alert dialog on error that we had added previously, and put a breakpoint in here. And then I can dismiss this alert and try to toggle the form type once again. And as we can see, our debugger now stops on this line. And if we inspect the local variables, we can see that this state variable is set to this async error value. And as a result, this condition will evaluate to true, and the error alert will show again. And to understand why this happens, we need to open our email and password sign-in controller class, and then we need to focus on the update form type method. And what this method does is to update the form type. But what it doesn't do is to modify the value. And in fact, this is only set inside the submit method, and it will be set to async value.error if our authentication call fails. So what is happening is that when we call update form type, then we set the state again, and as a result, then our widget rebuilds, and this listener is called again. And this will show an error because this value still has an error. And at this stage, there are two possible ways of fixing this error. The first one is to go back to our controller, and inside the update form type method, we can make sure that alongside changing the form type, we also set this value to async value.data with null. And this will make sure that as soon as the listener is called, then here we no longer have an error and the alert won't show. In fact, we can already test this by pressing this button to toggle the form type. And as we can see, we no longer get an error in the debugger. And if we continue running our app, then the alert doesn't show. But there is also another way of fixing this error. And what we can do here is to modify this listener and filter state updates so that we only listen to changes to the async value itself, but not to changes to the form type. And to show you what I mean, I can go over here at the end of this provider, and here I can type .select. And if we hover to reveal the documentation, we can read that this is a method that can be used to partially listen to a provider. And the way it works is that it gives us a function with a state argument, and we can use this to specify which property in our state class we want to listen to. So for example, we can return state, and if we press dot, we can choose whether we want to return the form type or the value. So if we select value, what we are saying is that we want our listener to never be called when the form type changes, because we only care about changes to the value. However, we now get a compile error because the type of this value is async value. And this means that we also need to change the type of our listener to async value as well. And we also need to be a little bit careful here because this state also has type async value. And this means that we should call state.showAlertDialog on error directly. And now that we have made this change, we can get back to our controller. And here we can remove this line because it's no longer necessary to reset the async value when we toggle the form type. And that's because our listener will only be called when the async value changes. And this doesn't need to happen when we update the form type. And as a proof of this, we can hot reload, and just to make sure that everything works as intended, we can close this page and then open it again. And then we can enter our email and password. And if we try to sign in, we can see that we get a loading indicator followed by an error alert because the async value has just changed. But what is really interesting is that if we try to toggle the form type now, we can see that we no longer get the error alert, meaning that this time the listener is not executed at all. And that's because the async value only changes when we try to sign in. And now that we fixed this bug, let me do a summary of what we have learned. And the main takeaway of this lesson is that when we watch or listen to a provider, we can use the select method to decide which property we are interested in, so that we only rebuild our widget or get a listener callback when this property changes. And as we have seen, this is quite handy because this listener only cares about changes to the async value. And now that we have verified that this works, we can get back to our fake auth repository, and then we can remove this line from here. And maybe I'm going to keep the delay so that we always get the chance to see the loading UI, like this. And if we want, we could add the delay in here as well. In summary, we have now completed the entire authentication flow for our e-commerce app. And since we have made a lot of changes along the way, chances are that something may not be working for you. And for this reason, you can find an updated code snapshot in the resources for this lesson. And by the way, let me point out that while we can now sign in and sign out, there are some things that we could improve, particularly in relation to our routing code. And in fact, in the next few lessons, we'll focus on GoRouter once again and learn how to use it to implement redirects and automatically update the navigation stack when the authentication state changes. Okay, so let's continue on the next lesson. In this lesson, we are going to learn about redirects using GoRouter. And the main idea behind this is that we don't want users to be able to see certain pages in our app unless they are signed in. And as you can see, over here I have the app running on Chrome and I'm currently signed out. However, if I go to the URL bar and append /orders to the URL, then I am taken to the orders page. And right now, this just shows some fake data, but once we implement this property, we will use this page to show the orders that have been placed by the user. And we should only be able to reach this page if the user is authenticated. So our goal is to use GoRouter to specify a redirect that sends us back to the home page if we try to reach this page when we are not authenticated. And of course, this means that we need to be able to check the authentication state. And this is something that lives inside the fake auth repository, which contains this method that we can listen to if we want to observe auth state changes. Or if we just want to read the current auth state, then we can just get the current user and see if it's null or not. So in the coming lessons, we'll use both of these methods so that you can better understand when to use them to implement some redirection logic. So our first step is to open the app router file, and inside the top level GoRouter object, we can add a new redirect argument, which is a function that gives us a build context and a GoRouter state. And the way this works is that this method will be called every time a new route is requested. And if we don't want to apply any redirect logic, then we can just return null, which is the default value that is applied if we don't supply a redirect argument. And in this case, GoRouter will work out what route to take based on the state and the definition of all the existing routes. But we can also choose to return a path to an existing route if certain conditions are met. For example, over here we could type const is logged in equals false. And this is something that we will update shortly by accessing the auth repository. And then we can type if is logged in. And then if this is true, we can check if the state.location is equal to /signin. And if that's the case, we can return /, which represents our homepage, because there is no reason to open the sign-in page if we are already logged in. On the other hand, if we are not logged in, we can use an else statement, and then inside it we can type if state.location equals to /account or state.location equals to /orders, and in this case we should also return /, because our intention is to not be able to visit the account and orders page if we are not signed in. But of course, all this logic depends on this line, which only works if we can read the current user from the auth repository. And if we want to access the auth repository, then we need to have a ref object. So what I propose we do at this stage is to create a provider of type GoRouter that we will use to return this GoRouter instance. So over here at the top, we can add a new provider and we can call this GoRouter provider, and this will have type GoRouter. And of course, we need to import Flutter Riverpod. And then, rather than declaring a global GoRouter variable like this, we can just return this entire object inside our provider. And we just need to go all the way to the bottom and make sure that we close the provider body correctly. And then we can save. And because now we are inside a provider, then we can declare a final auth repository equals to ref.watch with auth repository provider. And of course, we can import this. And now that we have our auth repository, then we can delete this code. And instead we can type final is logged in equals to auto-repository.current-user is not equal to null. So this completes the implementation of our redirect logic. But before we can use this, we need to go back to our app.dart file. Because we now have an error over here, since GoRouter is no longer a global variable. However, we can easily fix this by converting this widget into a consumer widget that we can import from Flutter Riverpod. And as usual, we can add a widget ref argument to the build method. And as a result, we can declare a final GoRouter variable equal to ref.watch with GoRouter provider, like this. And we can pass this object to the router config argument of the material app. And at this stage, we can save and hot restart. And then we can test our redirect logic. For example, we can go to the URL address bar and add /orders at the end. And then if we try to open this page, then we can see that we are redirected back to the home page. And that's because our redirect logic has worked out that we are not logged in when we try to access the orders path, and it has returned the root path instead. And another test that we could do is to try to sign in with email and password. And once we have done this, we can see that we are now signed in. So what we could try to do is to append /sign in to the URL address bar, and then we could try to go to this location. And surprisingly, this time we are taken to the sign-in page, which is not what we expected since we had this redirect logic in place. But one important thing that we need to keep in mind is that navigating to a given URL using the address bar is the same as restarting the entire application from scratch. And because we are using an in-memory store to store the authentication state, then this gets reset when we restart the app, meaning that we are no longer signed in after changing the URL. In other words, any application state that is not persisted to local storage or some remote backend will be reset when we change the URL in the address bar. And this is something that you want to keep in mind when you work with Flutter Web. And what this also means is that our redirect logic is working correctly, and we can continue on the next lesson. In this lesson, we are going to talk about refresh listenable, which is a feature of GoRouter that we can use to trigger custom redirect logic in response to a certain event. So let me show you how this works. And the main idea is that here we can specify a refresh listenable argument. And as you can see, this is an object of type listenable. And in Flutter, it is quite common to implement listenable by creating a change notifier subclass, because change notifier itself implements the listenable class. And in our example, we know that the authentication state changes every time the auth state changes stream emits a new value. This means that if there was a way to pass this method to the refresh listenable argument, then we would trigger this logic automatically when we sign in or sign out. So let me show you how we can use this, and then we can see what benefits we get in practice. So as a first step, let's try to pass auth repository.auth state changes as an argument. And as we can see, we get an error telling us that the argument type stream of app user can't be assigned to the parameter type listenable. And this makes sense because refresh listenable was designed to work with listenable objects. But if we look carefully at the documentation of GoRouter, we can find this redirection page, which includes a section about refreshing with a stream. And here we can learn about the GoRouter refresh stream class, which is used as a wrapper that we can use to work with streams. And just to be clear, this was a class that was included as part of the GoRouter package up until version 4. But as we can see from the changelog of version 5, then this class is no longer available. And the migration notes for version 5 tell us that if we want to use this class, then we should copy and paste it inside our code. So let's get back to VS Code and see how we can handle this. And what I'm going to suggest is that inside the routing folder, we create a new file called goRouterRefreshStream.dart. And then I'm going to paste the implementation of this class here. And if you are coding along with me, you can find the contents of this entire file in the notes below this lesson. So feel free to copy the code from the notes below and paste it in here. And now that we have this, we can get back to our main router. And all we had to do here is to wrap this stream with a GoRouter refresh stream like this and import this class from the file that we have just created. And as you can see, the error goes away. And for reference, I think it's useful to see how this class is implemented under the hood. And that is by extending a change notifier and by registering a stream subscription so that we can call notify listeners every time the stream emits a new event. And this means that you can use refresh listenable to work with streams using this wrapper, or work with listenable directly by implementing your own change notifiers. And as far as we are concerned, this is all we need to do. And to prove that refresh listenable does what it's supposed to do, we can open the account screen file, and then we can locate the logic for signing out. And here we can remove these 3 lines that call navigator.pop. And here we can remove this logic for checking the success status of this call. And since we no longer need to check for it, we can even remove the await keyword. And then we can open the signout method inside our controller, and we can modify this method to return a future of type void, and remove this return statement because we no longer care about the result. And then we can test our code. So as a first step, let's try to sign in with email and password. And then we get redirected to the home page. And from here, we can go to the account page and try to log out. And as soon as we confirm this, we can see that we are redirected back to the home page, even though we are no longer called navigator.pop explicitly. Likewise, we can go back to the email and password sign-in screen. And over here at the top, we can remove this callback that is used to pop the navigation stack. And then we can save and try to sign in again. So once again, we can enter the email and password. And as we can see, as soon as this succeeds, we get back to the home page. And this proves that our refresh listenable is triggered and the redirect logic is doing the right thing by sending us back to the home page. And as our applications grow in scale, this can be a big advantage because this means that we can have a centralized place to deal with routing in response to application state changes. And we no longer need to pop the navigator explicitly. And just for clarity, let me go back to the email password sign-in screen. And if we scroll down to the submit method, you may wonder if it's also okay to remove these lines, which are used to call this callback. And also, if we open the controller, would it be okay to return a future of type void and no longer return the error state? And at this point in time, this is the case, and our application would work just fine if we make this change. However, for now, we are going to leave this code as it is, because we'll make use of this callback later on when we reuse this signing form in the checkout flows. Okay, so let's continue on the next lesson. In this lesson, we are going to discover and fix a bug that we have introduced in the last lesson when we have added this refresh listenable argument to our GoRouter instance. And just to show you what the bug is, I can tap on this icon to open the shopping cart. And from here, I can go to the checkout. And as you can see, here we get a registration screen. And the reason for this is that we had to sign in or register an account before we can complete the checkout progress. And so far, this is all working as intended. However, if we enter a test email and password, and then we try to go ahead and create an account, then we should be taken to the payments screen. But as you can see, what happens instead is that a new registration screen is presented. And this didn't used to be the case before we added the refresh listenable logic. And as a proof of this, I can comment out this line, and then I can save and hot restart. And then I can open the shopping cart once again and move to checkout. And from here, I can enter the test email and password once again. And if I go ahead to create an account, then I'm taken to this payment page, which is exactly what is supposed to happen. So it looks like adding this refresh listenable has broken some of the navigation logic in the checkout flow. And it took me a little while to figure out what was going on. So to explain what the issue is, let's scroll down to the checkout route that we can find over here. And here we can modify this page builder code slightly by replacing this arrow notation with some curly braces. And then we can take this material page and move it inside it so that we can return it like this. And here we can add a debug print statement passing state.pagekey.value as an argument, which is a string that represents the page key used by GoRouter. And what this will do is to print this every time GoRouter decides to navigate to this route. And now that we have this, we can hot restart one more time. And we can also open the debug console. And then we can open the shopping cart and go to the checkout flow once again. And as soon as we do this, we can see a console log that says /cart/checkout P1. And here we can enter the email and password. And if we submit this, then the registration page shows up again. And we get another console log that says /cart/checkout. And there are two things that are strange about this. The first one is that the page builder is called again, even though we didn't ask to navigate to the checkout page explicitly. And the second one is that these two page keys are different from each other. However, we need to remember that at the top we have added this refresh listenable. And this is called every time the auth state changes. And this is definitely what happens when we sign in or register. And in fact, this refresh listenable is the reason that is causing this page builder to be invoked again. And for whatever reason, internally GoRouter has decided to use a different page key from the one that we had before. And this is a problem because if the keys are different, then Flutter will create a new instance of the checkout screen to be presented on top of the existing one. And for a good explanation about why Flutter does this, you should check this video from the Flutter team about when to use keys in Flutter. But for now, the bottom line is that if we don't want a new checkout screen to be presented on top of the existing one, then we should always pass the same key to this material page. And one way to do this is to remove this state.page key, and instead we can pass a value key with state.location as an argument. And just as a proof that this will always generate the same key, then here we can update this print statement to print state.location, like this. And now that we have made this change, we can hot restart one more time and clear the debug console. And then we can proceed to the checkout page. And we can notice that we get /cart/checkout on the console, which represents this location. And if we go ahead and register with email and password and create an account, then this time we are redirected to the payment page, which is the correct behavior. And we can see that we did get a second call to our print statement. And this means that our page builder was called again, but this time the key is the same as the old one. And as a result, Flutter has decided to keep the existing checkout screen in the widget tree without presenting a new one. And once again, this is the video that you had to watch if you want to understand this more in detail. And now that we have fixed our bug, we can remove this print statement. And we can simplify this code a little bit by using the arrow notation, just like we were doing before, like this. And the bottom line of this lesson is that because we added a refresh listenable, then GoRouter will rebuild the current route whenever the auth state changes. And this means that we had to be a bit careful about what keys we pass to our material pages, especially in this case because the checkout screen itself is a two-step process that we can use to sign in. And I should also mention that this was the kind of bug that can easily go undetected, because we have made some changes to the signing flows and a different part of the app did break as a result. And this kind of bug would have been discovered right away if we had some integration tests in place to check that the entire checkout flows work as intended. But we don't need to worry, because we'll be covering integration tests in the coming sections. And before we continue, I want to clarify that we still have a problem, because even though we are currently signed in, if we close this page and try to proceed to checkout once again, then the registration page appears. And this should only happen if we are not signed in. However, this is something that we will fix in section 9 of the course, where we will complete the checkout flows. So for now, don't worry about this, and we can continue on the next lesson. We have now completed the authentication flows, and we can now sign in and sign out as needed. And I feel that we have learned a lot of things along the way, including how to create a fake auth repository that uses an in-memory store under the hood. And we have also learned about how to work with state notifier when implementing controllers, which are the ideal place to hold business logic for updating the state of the widget, as well as calling methods inside our repositories. And we have seen that we can use async value.guard to simplify our controllers code so that we don't need to use try and catch blocks explicitly. And on top of this, we have learned how to access our controllers inside the widget using ref.read. And we have also seen how to listen to state changes using ref.listen. And we have created a helper method with an async value extension that we can use to show an alert dialog in a consistent fashion across all screens in the app. And finally, we have learned about redirect and refresh listenable, which are two useful GoRouter features that we can use to update the navigation stack in response to application state changes. And most important of all, we have managed to complete an entire feature by working on one layer at a time. And of course, we have covered a lot of ground, and if there are any concepts or steps that are not entirely clear at this stage, then feel free to ask questions. In any case, we'll build more features in our e-commerce app in the coming sections, and that will be a good opportunity to get more practice and cover some things in more detail. And just like I did in the previous sections, I have prepared some homework for you, and that is to grab the starter project for this section and see if you can re-implement the entire authentication flow without watching any of the videos. And if you need a little extra help, don't forget that all the lessons include a link that you can use to check all the code changes that we have made. And I think that completing this exercise will really help you to better understand all the material that we have covered. And once again, you can ask questions if needed. Okay, so that's all for now, and we can continue on the next section where we will learn how to write automated tests for some of the code that we have written.